Hello, this video is for the angle of elevation, angle of depression examples. This is our week 2, day 1 problem set for today. First, I'm going to go over how we look at angle of elevation and angle of depression examples with this worksheet that I have attached. Then we'll do some practice problems together, and then I'll tell you some assigned problems that you can work on. So when I think about angle of elevation and angle of depression, I think about like the word elevate. Elevate means that you're looking up. So if you look here, you can read what it says. It says when a person looks above his or her location, the angle between the line of sight and that person, the horizontal, is considered the angle of elevation. So this first triangle right here, drawn on the left, is talking about your angle of elevation. So you're looking up. A lot of times, like if you're looking up at a tree, you're looking somewhere down here, okay? Oh, I don't know what happened to that person. And he's looking up at this tree right up here, okay? Oops. And the line of sight is from kind of like his eyes looking up to the horizontal, down on the ground, okay? For angle of depression, the best examples are always about airplanes kind of flying and getting ready to land. So when I think about my angle of depression, it's like an airplane getting ready to land down here, and it's flying way up here in the sky this way, okay? And it's getting ready to land. As it looks down, that's the line of sight, and this is the angle of depression, okay? Well, the best way to do this is you must make sure, using a calculator, and you can use Desmos or you can use your cell phone, but you want to make sure that you are in degree mode, okay? Right here. All right, so if we look at this example, it says the angle of depression of the line of, the person stands at a window of a building so that his eyes are 12.6 meters above level ground in the vicinity of the building. An object is 58.5 meters away from the building on a line directly beneath the person. So the person is up here looking. Now, when I do angle of depression, you got to realize that the angle you're looking at from an object above is actually outside of the triangle. So what you have to remember from geometry is alternate interior angles allow you to use another angle in the triangle that you draw. So this angle down here is the alternate interior angle with the angle on the other side of the line of sight, okay? So really, you're really looking at this angle down here. And so if you think about your SOHCAHTOA from earlier this year and in geometry, what trig ratio are you going to use when the opposite side, so that's O, and the adjacent side are given to you? Well, you're going to use tangent. And so you say the tangent of the angle, theta, equals the opposite, which is 12.6, divided by 58.5. Now, to find theta, you got to look in your calculator or even on your cell phone or on Desmos, and you need to find tan inverse. Because when you're solving for this theta, technically we think about we're dividing both sides by tangent. So we're going to do tan inverse, and you're going to put in the calculator 12.6 over 58.5, and you get your angle 12.15. Okay? Okay, so now I've got the other attached document here with me, and this one's talking about the angle of elevation, angle of depression. All right, the good news is on the second page of this document, all the answers are given there, so you can check to make sure if you're doing this right. I just want to do the first 4 here together and then let you do some practice problems that we have attached. So this says the angle of elevation from point A to the top of the hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? So right over here is the drawing, and it gives you your angle 49 degrees. And it gives you your baseline, sorry, your baseline, not your baseline, your side part here. Apologize. It means that your horizontal is given, and your line of sight is the hypotenuse in this triangle here. Well, we're looking for the opposite side from the angle that is given. So if we look here, opposite side, and the adjacent side is given. So if you think about your SOHCAHTOA again, so you're going to get really good with SOHCAHTOA. Okay, so if we look here, which is opposite and adjacent? Well, its tangent is the one that's given, opposite over adjacent. So you're going to say the tangent of 49 degrees equals our opposite side, which is O, over our adjacent side, which is 400 feet. Okay, so for us to solve for O, we're going to multiply both sides by 400. Multiply both sides by 400. So then in your calculators, do 400. You can do this on Desmos, you can do this even on your cell phone calculators. Multiply 400 times the tangent of 49. And your answer is 460.15, and it's in feet. So make sure you have the units feet. Okay? Okay, so now let's look at the next example. It says, find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So what we're looking for right here is the angle looking up. Okay, so we don't know that angle. So if you look from that angle, 12.5 is the opposite side and 18 is the adjacent side. So we're going to use tangent again. So you're going to say the tangent, and you can call this theta, that's how I write theta, equals the opposite side, 12.5 over 18. If you remember in the previous part of this video, to solve for the angle, you must do inverse to both sides. So we're going to say to find theta, it's going to be tangent inverse, and make sure you're in degree mode, 12.5 over 18. So make sure you're in degree mode here. Okay? All right. Let's do some angle of depression problems. So I'm actually going to do two that are on the back here. Okay, so I've now turned this over to the other side. And what I'm doing is we're going to start with problem 6. So remember, we're going to write SOHCAHTOA. This is your sine, cosine, and tangent of your triangles. So this number 6 says the angle of depression from a balloon on a 75-foot string to a person on the ground is 36 degrees. How high is the balloon? So what you want to remember is if you look at what's given, that angle 36 is outside of the triangle you're really looking at. So by alternate interior angles, you're actually going to put 36 down below. So I'm going to redraw this just because that picture's a little small for me. But here's your angle of depression. Okay, this is your line of sight right here. So we're going to write 36 degrees inside this triangle. Here's your right angle. And now we can see that your hypotenuse is 75 feet, and the side we're missing is the opposite side. So where do you see on SOHCAHTOA where opposite is given, opposite is missing and hypotenuse is given? You can see that it's the sine. So we're going to say sine of 36 equals O over 75. And to solve, and this is in degrees, so to solve for O, we're going to do O equals 75 times the sine of 36. Okay? And if you look, our answer should be, on problem 6, you should have gotten, is 44 feet. Okay? Okay, so let's do the 8th example together, since this is another angle of depression problem. So it says, from the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. Again, recognize 19 degrees is outside of the triangle you're actually using. So for alternate interior angles, we know that 19 degrees is actually down here, okay? So we want to know how far from the base is the tower of the airplane. So really, our triangle that we're looking at here is using this angle, 19 degrees, and saying that it's 120 feet away from the tower. So here's 19 degrees. So we're given the opposite, and we're trying to find the adjacent. So if you look at SOHCAHTOA, which one is opposite over adjacent? It is tangent. So we're going to say the tangent of 19 degrees equals 120 over A. Okay? Now that A is on the bottom, we have to figure out how to solve for it. You can either cross multiply or just realize multiply by A to both sides. Multiply by A over here. So the A's cross off on the right, and now you have A times the tangent of 19 equals 120. So now to solve for A, you're going to divide both sides by the tangent of 19. And now you get A equals 120 divided by the tangent of 19. And again, make sure you're in degree mode. And when you check, you should get A equals 349 feet. Make sure, since we're talking about angle of elevation and depression, we are going to use our units. Okay, now I want you to practice the attachment on here that is called, I'm going to make it, it's these bookwork problems that I took from your book. They should be 65, 67 on page 340, and then 15, 19, 61, and 63. Let's see if I can get that right. Okay, so here's what I actually want you to do, is 61 and 63, and then 65 and 67. And I'm just looking at not 66, sorry, 65 and 67. Okay, so using what we just talked about, our angle of elevation and angle of depression, you should be able to do this. And then on the next page here, you're to do 15 and 19. Okay, and then for office hours, we'll go over these problems.